Look, we've all heard the hype around AI. Depending on who you ask, it's either going to revolutionize the world, do all our jobs, and free all our time to engage in creative pursuits, or it's going to leave us all unemployed and controlled by our robot overlords. We'll see which version of the future we end up with. But behind all the anxious excitement is a much more physical story. AI might sometimes feel weightless. You type in a query, an answer appears. But behind each query and response is a set of servers buzzing and humming in a machine somewhere, working away to deliver that answer to you. And those buildings, these vast data centers, are causing a huge surge in electricity demand across the world. But where will all that additional energy come from? Can our grids cope? And ultimately, will this transformative technology end up on a collision course with the clean energy transition? Hi, I'm Nimoy, an energy lawyer based in London. I advise the world's leading energy companies on major energy projects. And this is Energy Nook, where we're on a mission to demystify the complex world of energy. Today, we're exploring AI's energy problem. Let's get into it. To understand AI's energy problem, we first need to understand what's happening behind the screen. AI models are trained on vast data sets. This training requires a huge burst of energy over a relatively short period. But the energy use doesn't stop there. Once the model is trained, every time someone asks it a question, generates an image, uses an AI assistant, the model runs again. Millions or billions of these queries each day can add up to a major, continuous electricity load. And all that training and task processing happens inside data centers. Think of data centers somewhat like the warehouses of the digital economy. Vast buildings filled with servers, storage equipment, networking gear, and cooling systems. Globally, data centers are already major consumers of electricity. In 2024, data centers consumed roughly 400 terawatt hours of electricity. That's roughly 1.5% of global electricity generation. Now, that doesn't sound like a lot, but it's the direction of travel that really matters here. The IEA projects that data center electricity use could reach around 945 terawatt hours by 2030, or around 3% of global electricity use if current trends continue. But this growth in electricity demand is not spread evenly across the globe. It is concentrated in specific key geographical zones. Nearly half of all data center power consumption happens in the US. China accounts for roughly a quarter. And EU and the UK account for around 15%. So globally, data center electricity use might look manageable as a percentage of global generation. But the concentration matters because data centers do not connect to the global grid. They connect to a specific network in a specific place with specific constraints. And that's where the story starts getting a bit more complicated. In each of these geographies, the power grids are already under immense strain. And every new data center needs physical capacity in a real place. Enough generation, enough transmission capacity to move power across the country, enough local distribution capacity to deliver to the site, and enough substations, cables, and connection infrastructure to make the whole thing work. Specifically in respect of generation, the International Energy Association notes that developed economies face a wake-up call to invest rapidly in generation capacity to meet this growing demand from data centers. In much of the developed world, we're asking the grid to now meet the demand of these energy-hungry data centers at the same time that we're asking it to power electric vehicles, heat pumps, new industry, clean manufacturing, and the wider shift away from fossil fuels. Think about it a little bit like this. Data centers with their voracious appetites are arriving at the dinner table just as the cooks are already working at capacity to feed a table full of hungry guests. And in addition to the infrastructure challenges posed by the rise in electricity demand from data centers, there's the challenge of emissions. Whether AI increases emissions depends on what powers the data centers. They can use power from the grid, in which case their electricity mix reflects the grid they are connected to, or they can be supplied by dedicated sources that are purpose-built to power data centers. So this could be a solar farm, an on-site gas generation system, or even, in some cases, small nuclear reactors built specifically to meet the energy needs of data centers. At the moment, around 60% of global data center electricity comes from fossil fuels. Renewables provide 27%, and nuclear provides another 15%. Coal is the single largest source of electricity for data centers globally, largely because of China's power mix. What that means is, the energy required to power data centers is not always clean. The International Energy Agency expects renewables to play a growing role, with data center electricity moving from around 60% fossil today to around 60% clean power by 2035. But it notes that significantly more gas and coal generation could still be required to meet data center demand in the early 2030s, even as renewables grow faster overall. That is the uncomfortable physical reality underlying the AI revolution. Our infrastructure is not yet equipped to deal with these additional demands, and those additional demands may involve trade-offs with the clean energy transition. Now let's bring this home to the UK. The UK is in a bit of a bind. On the one hand, it wants to be a leader in AI, but it also has legally binding climate goals, including net zero greenhouse gas emissions by 2050 and a fully decarbonized power sector by 2035. This creates a balancing act. On one side, the UK wants more AI infrastructure, more data centers, and more digital investments. On the other, it needs to decarbonize its grid and relieve pressures on energy infrastructure. And the scale of this challenge is striking. Data centers currently consume around 2.5% of the UK's electricity, and that is expected to rise fourfold by 2030. In addition to building out additional generation capacity to meet that demand, to meet this challenge, the UK will also need to solve the grid problem. At the minute, the grid is a major bottleneck to meeting the demand from data centers. Nationwide, data center grid connection requests had tripled within a year by late 2025, far exceeding even aggressive demand forecasts. This surge in connection applications revealed the failings in the UK's grid connection system. In fact, in the Greater London area, so many data centers were approved that the local grid reached full capacity, reportedly delaying some new housing and commercial connections by several years. Part of the problem here is speculative demand. The grid connection queue is often clogged up by data center projects that will never actually end up being built, and the government is working together with Ofgem and NESO to solve this problem of speculative or phantom demand. But it also underlines the need for the government to plan more proactively. In 2024, the UK reclassified large data centers as nationally significant infrastructure projects, streamlining the planning process and signaling that data centers are now critical infrastructure. And in 2025, the government launched AI growth zones, designated areas where AI-ready data centers can be built with government support and faster approvals. And that tells you where we're going. AI is no longer just a tech policy issue. It is an infrastructure policy issue, an energy policy issue, and a planning policy issue all at once. Now, this is by no means a settled story. We are only just beginning to grapple with the energy implications of the AI revolution. There remain big uncertainties over how quickly AI will be adopted, how efficient AI models will become, and how many proposed data centers will actually get built. Equally, there are some who assert that AI may also help manage energy systems better. So the story is complex, but one thing is clear. The nations that win the AI race will be those that get the energy equation right. And where the UK ends up will depend on the choices we make today. Where data centers are built, how quickly grids are upgraded, and whether clean generation keeps pace with rising demand. Because the future may run on artificial intelligence, but artificial intelligence in turn runs on energy. Thanks for watching, and if you enjoyed that video, please leave a like and let me know in the comments what you think. And if you're interested in the forces powering our future, subscribe to Energy Nook. See you next time.